Welcome back to Statistical Reasoning. We are finishing up Chapter 1, Introduction to Statistics. We're going to do the third section, Collecting Sample Data. When you are collecting data, you may think of different ways. You can go talk to people, ask them to fill out a survey. You can observe people. There's lots of different ways, and we're going to talk about many of them, good and bad. One of the ways is we call a gold standard, and the gold standard is when you have randomization and when you have a placebo group and a treatment group that you can compare. A placebo group is a group that takes what's called a sugar pill or some type of option where you aren't really having the effect of whatever you're trying to do. And then you have your treatment group that is getting either the treatment, getting the pill, doing the exercise, whatever you're trying to do. We could either do an observational study and get our information that way, or we could do an experiment. When we're doing an experiment, we are actually applying some treatment and then we're observing its effects. For instance, maybe I believe that doing burpees is the best way to lose weight. And so I would have one group who would not do any burpees and I would observe their weight. I would have another group who's supposed to do 20 burpees a day, and then I would observe their weight and I would see what would happen. So I have my placebo group, which is the group not doing anything, and then I have my treatment group, which is the group doing the 20 burpees. But I'm asking them to do something, so that's an experiment. Versus an observational study where I would just go find people who happen to do burpees and see what they do. I'm not telling them they have to do them, they're doing them. I'm not telling them how many they have to do. So observational study, I just find people that are doing what I'm looking for and I write down as what's happening. An observational study could be something like an ice cream and a drowning. So I could go observe how many people eat ice cream or the sales of ice cream in the summertime. I could go see how many people are drowning. As we know, people tend to eat more ice cream in the summer, and people unfortunately drown more in the summertime because we swim more in the summertime when it's nice and warm. Now, just because both instances go up, ice cream sales go up and drownings go up, does not mean that ice cream sales are causing people to drown more. This is an instance where just because something might have a relationship, and here the case the relationship is both things are increasing, does not mean that one is causing the other one. And you need to watch out for that when you're dealing with statistics. Now, what would be better, though, in this case would be if we actually asked them to do an experiment, why we had one group who actually ate ice cream and we had a second group that did not eat ice cream. And then we saw just within those individuals how many of them accidentally drowned or not. Since we have two groups that were doing something and specific, we're watching them, not everybody who happens to have drowned, it would make it a better option versus an observational study. One of the things that you should try and do when you're designing an experiment is replication. In other words, you don't want to just do whatever you're looking for to one individual or one small group. You want to have a large sample size and make sure that you're following your rules with a large group, multiple individuals. Blinding is when people don't know if they're taking the actual pill or if they're getting the placebo. So when you're doing it medically, you have the group that they're taking a pill but it doesn't actually have any effect, that's the placebo or the sugar pill. Then you have a group that's actually taking what medication you think is going to be the next greatest treatment. They don't know what they're getting, that way it doesn't affect them. As far as their mental state won't affect what's going on. Double blind is not only when the person taking the treatment doesn't know if they're getting the actual medication or the placebo, but also the person who's giving them the medication doesn't know. Because unfortunately we are human and we feel for each other. So if I had a sick patient and they were helping me with this experiment, and I believed wholeheartedly that this medicine would cure them, if I knew they were getting the placebo, I might act different or say things differently to them than I would to people who were actually getting the treatment that I believed in. So because of that, it's better to do a double blind if you're dealing with a medical situation, so that not only does the patient not know what they're getting, but so does the person giving them the treatment. Randomization should always happen as much as possible, and that just means that everybody has the same chance of being chosen to do the experiment. So if you have 50 people lined up, you would figure out a way to randomly do that, where you assign them a number and then a computer generation maybe chooses their numbers, or there are some random number pages or charts that you can use. You could put numbers or names on popsicle sticks and have them chosen, so that nobody has more of a chance to being chosen as another one. Randomization. Simple random sample is when we choose sample size n, and again, everybody has the same option and same choice of being chosen. Systematic sampling is when we simply have every so many, in this case, cars. Every third car would be chosen to maybe have their tires checked to see if they're up to poundage. Every fifth person through a line at a coffee store would get a free coffee. Every 10th person would be asked to fill out a survey. That's systematic sampling. Convenient sampling is when you just ask whoever's near you to do something. We do this sometimes because it's the cheapest way to do it, but it's definitely not a good statistical habit or process. We don't always get a good diverse group to ask us or to help us with our survey. Stratified sampling is when you take a group or a population and you break them into smaller groups. In this case, we can see that it's done by gender. We have a male group and a female group. And then within each group, you randomly choose the same amount from both groups. 3 men and 3 women were chosen in this instance. There can be more groups than just 2 groups. Maybe you want to break something up by age group. You could have 5 different age groups, but then you would choose 10 people, for instance, out of each age group. That is different than the next one, which is cluster sampling. In cluster sampling, you also make groups, but instead of you choosing some from every group, you then do 1 group or 2 groups or 3 groups, and you do everybody in the group. So in the instance they're showing you they're doing blocks on a map. Instead of doing 5 people from each block, they would choose to do 1 or maybe 2 of the blocks and then talk to everybody on those blocks. Multi-stage sampling is when you, at different stages of the experiment, you do different sampling, and that also helps make it more randomized. At the end on your Blackboard, you should have a page that you can go to and that you can do some practice. It should have the answers for you, so you'll know if you're doing it right or not. Also, the problems in your textbook are asking you to practice this as well. Thank you and have a good day.